Hi guys, welcome back to our channel. I'm Shakur and today we are going to solve a new problem together. The structure in this problem looks really interesting and we'll try to fully understand it together. Let's read the question together. Knowing that the central portion of the link BD has a uniform cross-section area of 800 square millimeter, determine the magnitude of the load P for which of the normal stress in that portion of the BD is 50 megapascal. We know that sigma equal load divided by area, but here for BD we have sigma and area, and we should write it like this: FBD equal sigma multiplied by area. Now that we written the main equation, let's draw the free body diagram for link AC so the problem becomes easier to solve. I have the figure of structure and link AC here. We should draw the force and support reaction on it together. Here at support C, we have Cx and Cy, and we also need to place a force FBD. We'll assume the real direction of the FBD as shown. FBD. Let's use the formula we wrote earlier to find FBD here. FBD equal 50 megapascal. It means 50 multiplied 10 6 9 Newton divided by square meters multiplied by 800 square millimeters multiply 10 minus 6 square meter. That equals FBD equal 40 kilo Newton. All right. With FBD now, let's take moments about point C. That's knockouts Cx and Cy. So our equilibrium equation gets a lot simpler. I write it here. Sigma m about point C equal 0. It means now look at the here. We have this part of this figure, and that's 2. We should knowing BD for sine and cosine. For this we write this equation: BD equal 1.92 power 2 plus 0.5 0.56 meter power of 2. It's, I think, approximately equal 2 meter. Okay, that's 2 meter. And we know that sine, if we did that's alpha, sine alpha equal 1.92 divided by 2, and I think I write it here, it's better. Let's move it here. Alpha sine alpha equal 1.92 divided by 2, and cosine alpha equal 0.56 divided by 2. We know these two number and value, so let's write the equation. It means we have here f bd it's alpha, f bd cosine alpha multiplied 1.4 meter, and plus f bd sine alpha multiplied CRB, that's sine this length is 1.42, 1.4 meter, and minus p multiplied, here it's 1.4, and this part equal 1.4 sine 30, it's equal 0.57 meter. 1.4 plus 0.7, and we know that cosine alpha equal 0.56 divided by 2, and sine alpha equal 1.92 divided by 2, and FBD is equal 40 kilonewton. We want to achieve P. It's P equal minus FBD cosine alpha multiplied 1.4 minus FBD sine alpha multiplied 1.4 divided by that's equal 2.5 1, 2.1, and know that FBD and cosine alpha and sine alpha, write it here, minus 4t kilonewton multiplied 0.56 divided by 2 and multiplied 1.4 minus 4t kilonewton. Let's write it here. P equal minus 40 kilonewton multiplied 0.56 divided by 2 multiplied 1.4 minus 40 kilonewton multiplied 1.92 divided by 2 and multiplied 1.4 divided by 2.1. That's approximately equal 33.1 kilonewton. 33.1 kilonewton. That's it. It's a easy problem. I hope you find it useful.